Welcome to Fun Facts Online. In the vast, tangled web of the internet, a monster with a million heads is growing. This is the digital hydra of online hate. For every hateful comment we cut down, two more seem to sprout in its place. This hydra doesn't just spew venom, it whispers poison, slowly turning some people down a dark path towards extremism. Manually fighting this beast is impossible. Billions of posts, comments, and messages flow across the internet every single day. So how do you fight a monster made of words? You teach a machine to read its mind. Today, we're diving into the fascinating and fraught world of computational linguistics, where AI is learning to trace the labyrinth of online hate and map the breadcrumbs of radicalization. Let's get started. First, we need to understand the anatomy of the problem. Hate speech is any communication that attacks a person or group based on things like race, religion, or gender. Online, this venom spreads with terrifying speed. Extremist groups have become masters of social media, using it to broadcast their ideology and recruit followers. This recruitment process, turning someone from a casual consumer of content into a committed extremist, is called radicalization. It's a complex personal journey, but a pattern often emerges. Radicalizers are skilled at finding vulnerable people, those feeling lonely, angry, or isolated. They slide into DMs, not as fire-breathing extremists, but as sympathetic friends. They listen, they validate grievances, and they slowly introduce the person to an ideological echo chamber. In this chamber, all their fears are amplified, and a simple, toxic us versus them worldview takes root. Historically, radicalization was a hybrid process, a mix of online influence and real-world interactions. But we've seen a dramatic shift. Today, radicalization primarily online is becoming dominant. People are being drawn into extremism almost entirely through their screens. This makes the language they use our most important clue. But it's not always obvious. Extremists know they're being watched, so they camouflage their language. They use irony, sarcasm, and coded signals called dog whistles, phrases that sound perfectly innocent to you and me, but carry a specific, hateful meaning to their target audience. It's a deliberate tactic to fly under the radar of both human moderators and basic keyword-based bots. To fight this hidden language, experts have turned to computational linguistics, an incredible field that merges computer science and AI with the study of language. Its most famous application is natural language processing, or NLP, which gives us the tools to analyze extremist communication on a massive scale. So how do you teach a machine to understand language, especially language designed to be deceptive? The process starts with cleaning. Imagine you have a giant pile of raw text from a forum. First, the machine performs text pre-processing. It strips out irrelevant junk like URLs and HTML tags. Then it performs tokenization, which is just a fancy word for splitting sentences into individual words or tokens. Next comes lemmatization, where words are boiled down to their root form so running, ran, and runs all become run. Finally, it removes common stop words like the, a, and is, which don't add much unique meaning. Once the text is clean, the real magic begins: feature extraction. This is where the machine starts to understand the meaning. Early methods were pretty simple, like the bag of words model. This approach basically ignores grammar and word order and just counts how many times each word appears. A slightly smarter version is TF-IDF, which gives more weight to words that are common in one document but rare everywhere else, helping to pinpoint important keywords. But the real revolution came with word embeddings. Techniques like word2vec and glove represent words as a series of numbers, or vectors, in a high-dimensional space. The incredible part is that these vectors capture semantic relationships. In this vector space, the distance and direction between man and woman is the same as the distance and direction between king and queen. This gave machines a genuine grasp of context for the first time. Today, the state-of-the-art is a technology you've probably heard of: Transformers. Models like BERT, which stands for Bidirectional Encoder Representations from Transformers, have changed the game. Unlike older models that read text from left to right, BERT reads an entire sentence all at once in both directions. This allows it to understand deep context. It has an attention mechanism that lets it figure out which words in a sentence are the most important for understanding the overall meaning. This makes it far better at catching nuance, sarcasm, and the complex syntax that hate speech often relies on. After turning words into numbers, these numerical representations are fed into machine learning models. These models are trained on huge datasets of text that have already been labeled by humans as hate speech or not hate speech. By analyzing millions of examples, they learn the statistical patterns that define each category, becoming powerful classifiers. But detecting a single hateful post is just one piece of the puzzle. The real challenge and the true power of this technology lies in tracking the entire process of radicalization. It's about seeing the subtle shifts in a person's language over time that signal their descent into an extremist worldview. This is where computational linguistics becomes a form of digital forensics. Using a method called temporal analysis, AI models analyze a user's entire posting history over weeks, months, or even years. They look for critical changes. One landmark study did exactly this. Researchers analyzed the complete Twitter timelines of over 100 users who eventually expressed support for Daesh or ISIS. They found that as these individuals engaged more with extremist content, retweeting propaganda, interacting with extremist leaders, their own language measurably changed. They started using the group's specific in-group jargon, and their overall linguistic style began to merge with that of the extremist group. It was like watching their digital identity being overwritten. Another fascinating study looked at incel forums. Incels, or involuntary celibates, have a deeply fatalistic and misogynistic ideology. The analysis showed that when users first joined these forums, their expressions of anger, sadness, and their use of unique incel vocabulary shot up, before eventually leveling off. This suggests the forum acts as an ideological pressure cooker, taking pre-existing grievances and hardening them into a rigid, hateful worldview. These analyses create a kind of weather map of a person's radicalization, showing the fronts of anger and ideological conformity moving across their digital life. Beyond tracking changes over time, I can also identify the specific dialect of different extremist groups. Each group has its own unique ideological fingerprint, a specific set of enemies, dogmas, and jargon. The incel lexicon, for example, is built around an ideology they call the black pill, the belief that a man's worth is fixed by his genetics. This worldview is encoded in their vocabulary. Attractive men are Chads, attractive women are Stacys, and everyone else are normies. Their language is filled with themes of misogyny and resentment. By analyzing it, I can detect high levels of anger, sadness, and dehumanizing terms for women. White supremacist rhetoric is different. It's often more sophisticated, designed to create a collective white identity, while dehumanizing other groups. Researchers have trained AI models on content scraped from infamous forums like Stormfront. These specialized models learn to recognize the specific slang and rhetorical tricks used, making them far better at detecting this particular flavor of hate. By training models on these unique ideological fingerprints, it becomes possible not just to flag hate speech, but to identify the specific movement behind it, whether it's jihadist, eco-fascist, or something else entirely. Perhaps the toughest job for AI is decoding language that is intentionally designed to be misunderstood. Dog whistles are coded messages that seem harmless on the surface but signal something sinister to a specific audience. Extremists are now masters of what's sometimes called algospeak to bypass AI detectors. They might use the word soy as a dog whistle to attack men they see as weak or liberal, or use phrases that have plausible deniability. How can an AI know if a politician talking about cosmopolitan elites is just describing worldly people or using a classic anti-Semitic trope? Recent research is testing whether large language models like GPT-4 can crack this code. The results are promising. These models are getting better at figuring out if a word is being used in its normal sense or as a coded slur. Cracking this code is crucial for building systems that understand not just what is said, but what is meant. Finally, to get the full picture, language analysis is often combined with social network analysis. This technique maps the relationships between users, showing who is connected to whom and how information flows. When you combine the language data with the network map, the insights are incredibly powerful. A system can see not just who is posting hate, but who the superspreaders are, the key influencers at the center of a network. It can track how a piece of propaganda starts with one person and ripples out through their followers, and even how the language gets adapted along the way. This lets analysts see both the message and the map, tracking the viral spread of radical ideology across the social landscape. As you can imagine, using AI to monitor online speech walks a very fine line. The technology is powerful, but it's filled with technical hurdles and huge ethical questions. First, there's a never-ending arms race. Extremists are actively trying to fool the AI. They use adversarial tactics like adding strategic typos, putting spaces between letters in a slur, or embedding hateful text inside an image. One particularly clever method is the love attack, where they simply add a positive word like love or beautiful to the end of a hateful sentence. A simple AI model can get completely thrown off and misclassify the post as harmless. Researchers are constantly developing defenses, but as the detectors get smarter, so do the people trying to evade them. An even bigger problem is algorithmic bias. If an AI model is trained on a dataset where, for example, African American vernacular English is disproportionately labeled as offensive, the model will learn to flag non-hateful posts from that community as abusive. This leads to unfair censorship and digitally reinforces real-world biases. The problem is made harder because context is everything. A slur being reclaimed by an in-group to empower themselves is linguistically identical to that same word being used as a hateful attack by an outgroup. An AI without a deep, human-like understanding of social context can't tell the difference. For a long time, many of the best AI models were black boxes. They could give you an answer, like this post is 97% likely to be hate speech, but they couldn't tell you why. This is a huge problem. For moderation to be fair, a human needs to understand the AI's reasoning. This has led to the rise of Explainable AI, or XAI. These techniques are designed to make AI decisions transparent. An XAI system can highlight the exact words or phrases that caused it to flag a post. This allows a human moderator to verify the logic, catch mistakes, and build trust in the system. It's a critical step toward making AI accountable. And all of this is shadowed by the fundamental debate: freedom of speech versus online safety. Where do you draw the line between protecting people from harm and creating a system of mass surveillance? Proactively searching for radicalization pathways means analyzing the entire online history of individuals, raising profound privacy concerns. The road ahead in this field is moving fast. The future is likely multimodal. Hate isn't just text. It's memes, videos, and symbols. Future systems will need to analyze all these elements together to get the full context. We're also seeing the rise of counter-radicalization AI. The same tech used to spot radicalization could be used to fight it, by generating personalized counter-messages designed to debunk extremist talking points. But the reverse is also true. Extremists will use generative AI to create endless streams of sophisticated propaganda and deepfake videos, automating recruitment on a scale we've never seen before. The digital world is a reflection of us, in all our beauty and all our darkness. The spread of online hate is a complex, adaptive problem that no single technology can fix. But by teaching machines to understand the nuances of our language, the loud calls of hate, the quiet whispers of radicalization, and the coded signals hiding in plain sight, computational linguistics gives us a powerful new lens. It's not a magic solution, but it is an essential tool in the fight to understand the digital hydra, and hopefully, one day, to tame it. Thanks for tuning in to G Fun Facts Online.